Okay, so today we're gonna learn about inverse functions. Nothing too difficult, pretty straightforward. So definition of inverse function, you switch x to y, you solve for y. The important part is that under for x in the domain, just a bunch of words. Okay, well, we'll just start to the practice problems. Okay, for this one, find the inverse of the function of f. Informally verify that f of 1x is equal to x, and then f of 1 of f of x is equal to x. Okay, so we're gonna write y is equal to 6x. The only thing you have to do is to find the inverse, you just reverse it. X equals to 6y. Solve for y, divided by 6. So y is equal to x divided by 6. So this means that, going back to the original problem, f of 1 of x is equal to x over 6. So we're gonna rewrite it the y with f prime of x. Now, when we plug in the prime into x, we gotta make sure it equals to x, and then when we plug it in inverse, then it gotta also equal to x. Because that's what it's asking you is to verify. So the very first one is f of f prime of x. And this has to equal x in order for it to be true, right? So that means we're going to take this function and plug it into this function and simplify. So this is what it's going to look like. So f of prime of x is equal to 6 times x divided by 6, because that's what f prime of x is equal to. You simplify it, and you get x. So we're just verifying that it is indeed true. So we're plugging in the inverse function into the original function to verify that is indeed true. And then it has to be true going backwards. You have to plug in the original function into the inverse function. So now you have f of x, which is 6x. So f of x, I literally told you in the very beginning. And then you're going to plug it into your inverse function, which is divided by 6. Which when you simplify, you indeed get x. So this is true. And we just proved it by plugging it in. Does anyone have any questions? So just doing substitution into the equation. Okay. So if we do number 3, or in this case this one, same thing. Y equals to x plus 7. To find the inverse, we flip it. Y is equal to x minus 7, or x minus 7 is equal to the inverse function. So f prime of x. I'm sorry, -1. I gotta make sure I write the notation correctly. -1. Every time you have the little -1, it just means the inverse.
So much more confusing than it really is.
What?
I said when they write it out, like it looks way weirder and more confusing than it is.
Yeah, it just depends on how the way to write it.
Right. I'm s or f prime x equals x.
Yeah,
Which looks it's really just
a lot of x's.
yeah.
So we're gonna verify it by plugging it in. So it's always good to know which one you're gonna do first. So I'm doing f of prime of x. So that means I'm gonna have my original function and I'm gonna plug in my inverse function. So that means that my f of negative x is being plugged in. X minus 7 plus 7. I'm taking this function and I'm plugging it into my original function. That's what it means. Remember, taking my inverse function and I'm plugging it into my original function. And so when you simplify, x minus 7 plus 7 is just x minus 7 plus 7, which gives me just x. That is true. So now we're going to go backwards. F of prime and the inverse of f by f of x. So that means we're going to take our original function and we're going to plug it in to my inverse function. So x plus 7 is my original function and I'm plugging it in to my inverse function. Which when you simplify, x plus 7 minus 7 just gives me x. So it is indeed true. Just verified it. Does anyone have any questions? Oh, you got your function, you find the inverse, and then you just do substitution. The inverse into the original, and then the original into the inverse. So it's just substituting. Okay, let's move on. Number 2, show that f and g are inverse function algebraically and verify that f and g are inverse functions numerically by creating a table of values for each function. So we're gonna do it algebraically, and then we're gonna do it numerically. So first algebraically. So oops. Yeah, so we're just gonna plug it in. So algebraically means you're just gonna plug it in. So f of g of x. This has to give me x, and then g of f of x has to also give me x. So this is how you can verify it algebraically. Because we already proved it that if you have your function and you plug it into your inverse function and vice versa, if you get x, they are indeed inverse functions of each other. Does anyone have any questions so far? Okay, so this means we're gonna plug in g of x into my f of x function. So that means I have the square root of x squared plus 4 minus 4. Right? Right? Plugging in g of x into f of x. Simplify it. X squared, the square root of x squared, it's just x. So that means f of g of x is indeed x. So this checks out. Now we're going to do f of x up to g of x. So that means I'm going to have the parentheses, square root of x minus 4, parentheses, squared plus 4. So that means when you take the square root of the square, it cancels out. So take the square root of the square, they end up canceling out. And then minus 4 plus 4 gives me just x. So that means g of f of x is just x. So that checks out. They are indeed inverse functions of each other.
One question.
What's your question?
So they're inverse functions of each other, but if you graph that they're not inverse, because you can't have all the same points.
The thing is that for this graph,
I don't really care.
no, it doesn't really
So
count.
what specifically?
It's for x is greater than or equal to 0. So that means because of that restrictions, they are indeed inverse functions. And that's how we're going to do it in the next part. So let's say we're going to graph it, right? So this is where you're going to do it numerically with the table. So we're gonna do f of x, right? Is equal to the square root of x minus 4. And this is where we're going to create a table. Now, what restriction does my square root have? My radical. What's the restriction for
X has to be greater than or equal to 4.
Right. No matter what, it has to have that restriction, right? You can't plug in -5, you can't plug in -6. There's a domain restriction. So that means if I was going to create a table, what should my very first coordinate, x coordinate be? 4. When I plug in 4, 4 minus 4 gives me 0. And the square root of 0 is just 0, right? Now, if I want to plug in the next coordinate, what number would you plug in and why?
5.
No, actually, yeah, 5 is a good one. Because when you do 5 minus 4, you get 1. Very good. I probably should have done this one in the notes, but I didn't. But you get 1. Okay. And then what should my next one be? 8. Very good. Because when I plug in 8, 8 minus 4 is 4, which you can actually take the square root of, right? So very good, very good. All right, one more. What's another coordinate you guys could put in? 13. 13 minus 4 is equal to 9, which is the square root of 9 is 3. So very good. We'll just use these coordinates. We don't care about 6 or 7 or 9, 10, 11, or 12 because we want just perfect numbers. We don't want decimals. So those are very good perfect numbers because by now you should all know what the square roots of perfect squares are, right? 0, 1, 4, and 9. Okay. So now we're going to create the table for the other function, the g of x. Now the thing about this one is that it has a restriction. It was x squared plus 4. Now the domain for this is all real numbers, right? Because it's a parabola, you can plug in any value, get any coordinate back, right? But the thing is, you have to be very careful. It has a restriction of x is greater than or equal to 0. So that's very important. So that means the values that you plug in must be greater than or equal to 0. So that means the first number that I will plug in would be 0, right? 0 squared plus 4 is 4, right? What would the next one be?
1.
1. 1 squared plus 4,
5.
5. Which one would be the next one? 2. So then 2 squared is 4 plus 4 is 8. And then you could do 3. 3 squared plus 4 is 13. Well, look at that. It turns out they are inverse functions. If you look at the table, the x and y are reversed between both equations. So this proves it numerically that they are indeed inverse functions, but they are only inverse functions because of this restriction. If you didn't have the restriction, then it wouldn't be. Does that make sense?
Next one would just start.
So that's a
stop.
little, huh?
The phone would just stop.
Yeah. Exactly. So you have to be very, very careful. When you get to the homework, you'll see that some of the equations actually have restrictions, and that's the very important part that you have to know that you didn't know before is that you have to have some of them have to have restrictions in order for them
So
to
if it
be
doesn't have
inverse.
the restriction, then it would just be the functions are inverse, basically.
Yeah. Yeah. Because technically speaking, these aren't inverse unless this equation here has this restriction here. Does that make sense?
Yep.
So just be very, very careful. That's the only thing you do have to pay attention to. Okay, if AB lies on the graph of F, then the BA must lie on the graph of F of -1 and vice versa. So this is just going back to it again. And the graph in the inverse function is a reflection and the y equals x. So if you have what's it called, two graphs, they're only inverse if they're a reflection across y equals x. So that's another thing you can do to prove that they are indeed inverse of each other. Does anyone have any questions? Okay, So we have the following coordinates. 1, 3, 2, 3, 3, 3, and 4, 3 is a function, but the inverse is not a function. Why would the inverse not be a function? What would you guys think? Well, yes.
Because it does not pass the horizontal line test,
Which one?
the inverse.
Okay, so how would I know what the inverse be of these coordinates?
The inverse is the exact same, right?
No.
The inverse would be 3, 1,
Very
3,
good.
2.
3, 1. Very good. So that's what I'm looking for. 3, 2, and then 3, 3, and then 3, 4, right? Because this right here is the inverse of this, right?
Oh, wait, yeah.
Right? Because we just learned in the other previous problem that they're inverse when their x and y's are flipped, correct? So this is a function, correct? But just like Tristan said, this is not a function because this doesn't pass the horizontal line test. So
It kind of does. It is the horizontal line test. This is the horizontal line.
not a function. And yes, you could say it because what's it called? Remember, in order for it to be a function, every x coordinate has to go to one distinct coordinate. In this case, 3 repeats itself and it goes to multiple y coordinates. Does that make sense? Okay. To have an inverse function, a function must be 101. A 101 is no two elements in the domain correspond to the same element in the range. So y values can repeat. Unlike here, the y values do repeat, right? And then the horizontal line test f of a is equal to f of b. So right here, uh, if your y coordinates repeat, then you know for a fact the inverse function is not a function. So that's pretty much a shortcut. So let's do the next example. It says determine algebraically whether the function is one-to-one, and if it is, find its inverse function. So in order for it to be one-to-one, then you're going to use the corresponding f of a is equal to f of b. So this means you're just going to plug it in. So 3 times a plus 5 is equal to 3 times b plus 5. That's what it means. When you want to find a one-to-one, you plug in a for the function, the left side, and then b for the right function. You're just doing substituting. So we have 3a plus 5 equals 3b plus 5. Subtract 5 to both sides. Cancels. You're left with 3a equals 3b. Divided by 3. A is equal to b, which is indeed true for one-to-one function. So it's pretty much a shortcut. That's what the correspondence of f of a is equal to f of b means. Anyone have any questions? Yeah. So now we have to find the inverse. So f of x equals 3x plus 5. Y equals 3x plus 5. You flip it. X equals 3y plus 5. Subtract. Divide. And you have your inverse function. So the original equation is f of x equals 3x plus 5. And then the inverse function is x minus 5 divided by 3. And those two would be your answers. F of x equals x plus 4 and g of x equals 2x minus 5 to find the specified function. So the inverse function of the inverse function of g. So first things first, gotta find the inverse function. Y equals x plus 4, you flip it. Oops, did not flip it. Solve. Y equals to x minus 4, f of, and then just f of prime. So the inverse function of x plus 4 is x minus 4. And then you just gotta find the inverse of g of x. So y is equal to 2x minus 5. Sorry, not y. X is equal to 2y minus 5. Add 5, divide by 2. So g of prime, or the inverse of g of x is x plus 5 divided by 2. Mhm. Okay. Now we're trying to find the inverse of fog. So f of -1 of g of -1, it just means you're going to take your inverse of g of x and you're going to plug it into the inverse of f of x. So that means you'll have something like this. So plugging in inverse of g of x into f of x. So that just means you're going to take this function right here and you're going to plug it in into your f of x. That's just what it means. You're going to take that function, plug it in. So that means you're going to have, anytime you plug something in, I always do parentheses because you might have to do distribution sometimes.
Yeah.
What?
So it's also just neater when you write it.
Yeah. So then you'll have x plus 5 divided by 2 minus 4. Okay, here's the tricky part because you can actually reduce this and simplify this further. Does anyone know what to do? So that's the tricky part because I mean, technically it's not wrong, but you can make this look a lot nicer.
Uh, it's -3. Because you can, make the -4 and -8/2, and then it becomes.
So it's the inverse of simplifying. You're going backwards. That -4 can be rewritten as -8/2, right? So it's kind of the opposite of reducing it. You're kind of writing it, you're combining it by having like terms. So you can add the fractions together. So, and then if it helps, you can split it up. So you'll have x divided by 2 plus 5 divided by 2 minus 8 divided by 2. It just makes it look nicer when you reduce it as much as possible. So that's where Braden got 3 because 5 halves minus 8 halves will give you -3 halves. And obviously, when you're adding and subtracting fractions, you try to simplify it by adding the the numerators. But in this case, x and -3 cannot combine, right? But you can put them all under the same denominator. So the answer on the book will give you this, x minus 3 divided by 2, even though this is how far you got of x plus 5 divided by 2 minus 4. So you got to be able to know how to simplify it even further. That's the only trick part in case like you get this far on problem like this is that you can simplify it even further by having common denominators. It's not too hard, but you really gotta look at it. But like, how can I combine 5 halves and -4? Well, you can take -4 and make it to -8 halves. And then that will combine with 5 halves to give -3 halves. And then you can put it back together by writing x minus 3 divided by 2. And so I think that would be the answer in your textbook. Does anyone have any questions? So really tricky ones, but not too impossible. Okay, the last one says determine whether the equation represents y as a function of x, and all you have to do is solve for y. So in this case, negative y equals -4x plus 3, divide by -1, 4x minus 3. Is this a function y equals 4x minus 3? The answer is yes, because it's a linear function. Now for the next one, x squared plus y squared equals 9. So if you solve for y, negative x squared plus 9, and then take the square root, negative x squared plus 9. But in this case, as I told you before, when you take the square root, you gotta include the positive and negative. So would this one be a function, yes or no? No, because what kind of function it is this, even though we solved for y, what kind of function is this?
Absolutely not. Quadratic.
Nope. Learned it last year. Math 3. What kind of function? It's very similar. It's a circle. X squared plus y squared. Remember? You guys learned circles last year? The radius is 3. The center is 0, 0.
Yeah.
Right? Circle. So this is x minus h squared plus y minus k squared equals r squared. That's a circle. The only thing is that the center is 0, 0. So obviously this is not a function. Don't forget the circles. They're very pesky.
Showed up out of nowhere.
Yep, exactly. Honestly, the thing about what makes pre-calculus hard is that some things just show up out of nowhere. You're just like, what? So, yeah, gotta know circles. All right, other than that, that is it. That is today's lesson.